Hello guys, I'm Bob. In this video, I will be showing you the solution to the Maclaurin series of square root of cosine x. But before I do so, if you guys like this video, help me press the thumbs up icon. We can express the Maclaurin series of square root of cosine x using the formulas in the top right hand corner. The formulas in the top right hand corner tells us that a function of x can be expressed as an infinite series. We are going to solve this problem and expressing the Maclaurin series of square root of cosine x up to and including the x cubed term. For the first step, we are going to find what is s0. It is the function of x evaluating at x equals 0. F prime 0 is the function of x differentiating once and evaluating at x equals 0. F double prime 0 is the function of x evaluating at x equals 0 after differentiating 2 times. And f triple prime 0 is the function of x differentiating 3 times and evaluating at x equals 0. We let fx be equals to square root of cosine x. We first find what is my f prime x, which is just half the cosine x to the power of negative half. Differentiating cosine x, we get negative sine x. As for f double prime x, we will apply the product rule of differentiation. First, differentiating this part, we get negative 1/4 cosine x to the power of negative 3/2. Differentiating cosine x, we get negative sine x times negative sine x is just sine x the whole thing square. And then we will differentiate negative sine x, we get negative cosine x, keeping the rest as it is. Next, we simplify f double prime x and we get the following. Once we have the simplified form of f double prime x, we can move on to find what is my f triple prime x. So from the first term of the f double prime x, we differentiate the negative 1/4 cosine x to the power negative 3/2. Applying the product rule of differentiation, we get 3/8 cosine x to the power of negative 5/2. Differentiating cosine x is negative sine x times sine x squared is just negative sine x cubed. And then we will differentiate sine x the whole thing square. We get 2 sine x cosine x times negative 1/4 cosine x to the power of negative 3/2. And then we will work out the last term of the f double prime x. We get the following, which is 1/4 cosine x to the power of negative half. Differentiating cosine x to get negative sine x. We simplify the whole equation and we get the following. We have found my fx, f double prime x, f triple prime x, and f prime x. Next, we will evaluate substituting x equals to 0 into all this function. So let's just start working from fx, substituting x equals to 0. We just square root of cosine 0, which is equals to 1. So my f0 is 1. How about f prime 0? We substitute x equals to 0 into f prime x. We get the following, which is 0 because sine 0 is 0 and anything times sine 0 is equal to 0. How about f double prime 0? If we were to focus on the first term of f double prime x, if we were to substitute x equals to 0, the first term itself is equal to 0. How about the second term? The second term, substituting x equals to 0, we get just basically negative half. So f double prime x is negative half when x is equal to 0. How about f triple prime 0? If we were to focus on the two terms of f triple prime x, it contains sine x. So if we were to substitute x equals 0, both terms will just become 0. So now we have my f0, f prime 0, f double prime 0, and f triple prime 0. We can now apply the formula shown in the top right hand corner to find the Maclaurin series of cosine x up to and including the x cubed term. So my f0 is 1 plus f prime 0 is 0, so we will just skip. So for the third term, it's just x squared. F double prime 0 is negative half over 2 fact. How about f triple prime 0, f triple prime 0 is 0, so this term itself is just basically 0. Finally, the Maclaurin series of square root of cosine x up to and including the x cubed term will be 1 minus away 1/4 x squared. If you guys like the solution, help me press the thumbs up icon and do consider to subscribe. My name is Bob, thank you guys for your support, and I will see you in the next video. Goodbye guys.